Welcome to Kafka Internals Interview Crashcasts, the podcast that helps you prepare for senior backend engineer interviews. I'm your host, Sheila, and today we're joined by Victor, an experienced Kafka engineer. Victor, thanks for being here with us today.
Thanks for having me, Sheila. I'm excited to dive into Kafka internals with you.
Great. Let's jump right in with our interview question for today. What is Apache Kafka? And how does it differ from traditional messaging systems?
Excellent question, Sheila. Apache Kafka is a distributed streaming platform. Think of it as a super-powered message system that can handle massive amounts of data. It was originally developed by LinkedIn and later open-sourced. At its core, Kafka is designed to handle high-throughput, fault-tolerant, and scalable data streaming.
That's a good start, Victor. Can you break down what you mean by a distributed streaming platform for our listeners?
Certainly. As a distributed streaming platform, Kafka allows you to publish and subscribe to streams of records, similar to a message queue or enterprise messaging system. However, Kafka goes beyond that. It stores these streams of records in a way that's resistant to failures and can process them as they occur. Imagine it as a super-reliable, high-speed conveyor belt for data.
I see. Now, how does this compare to traditional messaging systems?
Traditional messaging systems, like RabbitMQ or ActiveMQ, typically focus on reliably passing messages between different parts of a system. They're great for things like sending emails or processing orders. Kafka, on the other hand, is built for scenarios where you need to handle massive amounts of data quickly. It treats messages more like entries in a logbook that can be revisited.
That's an interesting comparison. Can you dive deeper into Kafka's architecture and how it achieves this high throughput?
Absolutely. Kafka's architecture is based on what we call a distributed commit log. It organizes data into topics, which you can think of as categories. These topics are further divided into partitions. Each partition is like an ordered, unchangeable sequence of records that keeps growing. This design allows Kafka to handle massive amounts of data efficiently, like a well-organized library that can quickly file and retrieve books.
That's a helpful analogy. How does Kafka ensure scalability and fault tolerance?
Kafka achieves scalability through its partitioned log model. Each partition can be hosted on a different server, allowing a topic to scale horizontally across a Kafka cluster. It's like having multiple librarians working on different sections of the library simultaneously. As for fault tolerance, Kafka makes copies of these partitions across multiple servers. If one server fails, others can step in, ensuring the library stays open and functional.
Very interesting. Can you give us some examples of use cases where Kafka shines compared to traditional messaging systems?
Certainly. Kafka excels in scenarios requiring high-throughput data pipelines, stream processing, and event sourcing. For instance, it's great for real-time analytics, like tracking user behavior on a busy website. It's also perfect for log aggregation, collecting and processing logs from multiple systems in real time. And it's ideal for building large-scale event-driven architectures, like in IoT applications where you're receiving data from millions of devices.
Now, let's consider some edge cases. How does Kafka handle message ordering across multiple consumers?
That's a great question, Sheila. Kafka guarantees order within a partition, but not across partitions. If you need strict ordering across all messages, you'd need to use a single partition, which limits scalability. In practice, many applications can work with per-partition ordering. They often use strategies like partitioning by key to ensure related messages end up in the same partition, like keeping all messages from one user in the same partition.
Excellent point, Victor. What about message retention? How does Kafka handle that compared to traditional systems?
Kafka treats messages as part of a log, which allows for much longer retention periods than traditional messaging systems. You can configure Kafka to keep messages for a specific time period or until a size limit is reached. This is like having a library where books don't get removed for a long time. It enables use cases like replay and reprocessing of data, which are often challenging with traditional messaging systems that typically delete messages soon after they're consumed.
Thank you, Victor, for this comprehensive overview. As we wrap up, what advice would you give to candidates preparing for Kafka-related interview questions?
My pleasure, Sheila. For candidates, I'd recommend focusing on understanding Kafka's core concepts like topics, partitions, and the producer-consumer model. It's also crucial to grasp how Kafka achieves high throughput and fault tolerance. Don't forget to think about real-world applications and potential challenges in implementing Kafka-based solutions. And always be ready to explain these concepts in simple terms, as we've done today.
Excellent advice, Victor. To our listeners, remember that interviewers are often looking for not just knowledge, but also your ability to apply that knowledge to solve real-world problems. Be prepared to discuss trade-offs and design decisions when using Kafka. That's all for today's episode of Kafka Internals Interview Crashcasts. Thanks again to Victor for sharing his expertise, and thank you, listeners, for tuning in. Until next time, keep streaming and stay distributed.